So we have a few different situations where we're looking at conservation of energy. Let's start over here. So we have a diver on a platform. We're told at the top here, the diver has a potential energy of 15,000 joules and kinetic energy of 0. Diver jumps off the platform. As he or she falls, what happens to his energy? Turns into kinetic. So the potential energy is turning into kinetic, but the total energy is staying constant. So the sum of potential plus kinetic has to stay 15,000 joules. So if his potential energy here is 11,250, then his kinetic energy, excuse me, needs to be 3,750, so that the sum is still 15,000. Continues to fall, his potential energy continues to decrease, but his kinetic energy is going to increase in relation so that the sum always equals 15,000 joules. And continuing on, kinetic energy keeps getting bigger until finally, at this lowest point, the energy is all kinetic. So all 15,000 joules is what the diver has at that point. But now it's in the form of kinetic energy instead of potential energy. So it's just changed form is all. Okay? Questions on this one? Incline. We have the ball rolling down an incline. We're told at the bottom that the potential energy is 0 and the kinetic energy is 50. So halfway here, if the potential energy is 25, then the kinetic energy needs to be 25. So we have a total of 50. The total amount of energy must stay constant. Okay? Up at the top, we're going to have all 50 joules for our potential energy. Our pendulum on the bottom, mass on the end of a string swinging back and forth. At this location, it's been pulled to the side. It's not moving yet, so all the energy is potential. So 10 joules of potential energy. The ball is let go, so it starts to swing down. At this instant, it has 2 joules of potential energy. So it must have 8 joules of kinetic energy to add up to be the total of 10. At this lowest point, the potential energy is 0. The kinetic energy is then all 10. When it swings back up to its same original height, it has to have the same original potential energy. Okay? Remember, potential energy depends upon height and mass. The ball hasn't changed at all, so the mass isn't any different. If it gets back to the same height, it has to have the same potential energy, which means there can be no kinetic energy at that point, because we can't end up with more total energy than we started with. So it has to come at that instant back to rest. So we have a ball on top of a platform, equal size incline, same height, so it has to have the same amount of potential energy. Potential energy is dependent only on height. It doesn't matter how it gets from one height to the other. It depends only on height. So whether it falls straight down, say the ball falls straight down to the ground, or rolls down to the ground, as long as there's no friction and drag taking energy away, then, well, actually, disregard that. If they're at the same height period, regardless of where they start, as long as they're at the same height, they're going to have the same energy. Assuming it's the same ball, same mass. So this one will have 30 joules as well. This one going out in steps, the steps are equally spaced, so if this is 30, this would have to be 20. If a ball was here, it would be 10, down to 0 for potential energy. If the ball fell off the edge right before it hits the ground, all of the potential energy would have turned into kinetic energy. So it would have 30 joules of energy. Okay. Sorry, this line was kind of hiding, so don't worry about it.
Oh, good.
Yeah, it was offset from the picture. Okay, this one. If I have a car traveling at 30 kilometers per hour, this particular car happens to have 10 to the 6th joules of energy when it's traveling that fast. So if the car speeds up so that it's going twice as fast, same car, twice as fast. Kinetic energy, we know, is 1/2 mv squared. Same car, so the mass hasn't changed. But what have we done to v? We've doubled it. So 1/2 m 2v squared is the same, 2 squared is 4. 4 times 1/2 mv squared. So 4 times whatever original energy you had. This is not the same thing as that. You can't just multiply the 1 by 4 because it happens to be there. 40 to the 6th means 40 times 40 times 40 times 40 times 40 times 40, which is very, very different than 4 times 10 times 10 times 10, 10, 10, 10. Okay? So 4 times 10 to the 6th. What will this one be? 9 times 10 to the 6th. So 30 to 90 was tripled. 3 squared is 9, so 9 times 10 to the 6th. What's that? Questions on any of those?